Here we're going to have a look at 2018 question 9 part B. So we have a thin uniform rod floating in a piece of water suspended at point A. Now one of the tricky bits here is we don't know how much of the rod is in water. So we need to begin to put some labels on this one. So if we look at our rod here, there it is suspended from point A and it goes down. Well, we know the whole rod is the length of the rod is 2h. So being nice to us like that. And let's put our little bit of water here. There we go. Probably a little bit more of the rod and water than that, I think. There we go. Okay, so if the whole thing is 2h, we need to figure out this section here. So the section that's underwater. Now I'm going to call this 2x. All right. Why 2x instead of just x? Well, the halfway point is where the buoyancy force is going to be acting, coming upwards. There's our buoyancy. So of course if it's 2x, x and x each side, a whole lot easier. Same way if it's 2h, we can see that the weight acting downwards is going to be about there. There's our weight coming down. We'll have h distance here and h down there. Okay, so this is a little bit easier to work with. Now this section here then, so say our 2x is from there to there. So that means this piece here is 2h minus 2x, which is the piece from there to there. All right, 2h minus 2x in rather scribbly 2. Okay, so let's see where we're going to go first with this one here. Let's have a little look at our buoyancy force. So the buoyancy is W over S, again when we're in water. Okay, remember that W is the fraction submerged. So the buoyancy, how much is submerged? Well, 2x over 2h times W. All right, because 2x is submerged and the total length is 2h. And that is over S. So let's just do a little bit of rearranging here. And we get 2x over 2h by W over S. A bit easier to see it this way. And that is going to equal, they're going to cancel out. So xW over hs. So there's my buoyancy force. Okay, now this x is going to be a little bit of a problem. So we need to begin to figure out what can we, how can we approximate it. So the one thing we are told is the angle is 45 degrees. Well, that's a little bit nicer. Let's draw a triangle. So there's a little triangle, pretty much 45 degrees. And if we look at the section here, we know that this height from there to there is h. So this helps, this does give us some information. So fundamentally we have some idea, or we can figure out how much is underwater. So let's put that bit of h. We'll deal with the bit above water here. So that's 2h minus 2x. So this whole section here is above water. Well, we can relate these using this one here because that is the cos of it. So the cos of 45 is the adjacent over that. So it's going to be h over 2h minus 2x. We know cos of 45 is 1 over root 2 equals h over 2h minus 2x. So we'll do a little bit of rearranging here. We're running off the page. Oh, we have a little bit more space. So we have 2h minus 2x, bring them up there, equals root 2h. I'm interested in my x's. So bring the x over this side. 2h minus root 2h equals 2x. We're going to have to go up here a little bit. Up here. Divide everything by 2. Put x over here. X equals h minus, now root 2 divided by 2. I'm just going to do this out longhand just in case our algebra is a little bit sketchy. Root 2 over 2h, and that equals, of course 2 is root 2 by root 2, h minus 1 over root 2 h. Alright, so now I have a value for x. It isn't pretty, but I have a value for it. Okay, so we are getting there. We need to find out our relative density. So one of the standard places we go in these equations is going to be moments. So I think we're going to kind of bring ourselves up here. All right, keep it all nice and neat. So we're going to look at moments. Now, what will we go about? Well, I think in this case we're going to go about the point A. All right, moments about A. Well, coming down this way, we have W. What is our distance from there to there? Well, it is h sine 45 by h sine 45. Remember, it's the distance perpendicular to the forces we're interested in. Now, that is going to be equal to our buoyancy force going upwards. So we'll put on buoyancy. What distance have we got here? Well, that's h. That's 2h minus 2x to here, plus x there. So our distance is 2h minus x, and again sine 45. Okay, so in this case we can begin to do a little bit of tidying up. First of all, I'm going to lose the sine 45s. We have them both sides, and that's why you can sometimes shortcut this by using the distances along here, even though strictly speaking it is the distance perpendicular to the forces. So we'll get rid of those. We need to put our buoyancy force in. So we have that over here. So we have WH equals XW over HS by 2h minus x. All right. Now, I have an x here, and that's the one thing I'm going to get rid of. Before I do it, I'm going to do a little bit of tidying up before I substitute this value in for x, because this is going to get messy when I put it in, especially if I put it in when it's in all over the place. So let's see what we can do. We can first of all knock out the w on both sides. All right, that's good news. And we'll bring this hs over here. So I have h squared s equals 2h x, ooh, nearly forgot that little chappy there, 2hx minus x squared. Okay, it's about as neat as it's going to get, so we'll sub in x, hs squared equals 2h factor of h minus h over root 2, may as well make that a little bit tidier, minus h minus h over root 2, all to be squared. Okay, all right, fun times ahead of us here. So now what I am hoping is we have a whole load of h's we can cancel out. So I think I'll multiply this little step out, and then we'll begin to knock out some of those ones. So I'll leave the h squared s over here is 2h squared minus root 2, because 2 divided by root 2, h squared minus h. We need to multiply this all out, don't we? Minus h squared. Now, if we're going to do this one, it's going to be 2 times the value of that. So 2h over root 2, deal with that one afterwards, minus h squared over 2 plus h squared over 2. Okay, it's ugly. H squared s equals 2h squared minus root 2h squared minus h squared plus, again, that is going to be root 2h minus h squared all over 2. A lot of h squares I can combine here. So h squared s equals 2h squared. So we're just kind of mark these as we go so we don't lose track too much. That's a h squared and that's a h squared. So I end up with 2 minus 1 minus a half. So that is h squared over 2 half h squared. And these guys, oh, look at that. Isn't that just lovely? They cancel out. There was, of course, an s there. Dividing both by h squared, s equals half. So looked ugly, looked messy, but persevere, watch your pluses and minuses, and it all comes out in the end.